Welcome to part 1 of Competency 5 quiz questions. In this video, we will continue to work with properties of functions. Number 1, set H equals, and we have 1, 2, 3, 4 ordered pairs, and we have an ordered pair that's blank. The question is, which one of the following ordered pairs, when used to fill in the blank, would guarantee that H is not a function? Okay, what we need to do to satisfy not being a function is each of these x values, one of them would be repeated. That's what we're going to do. We're going to look at it. Okay, so A, no, 2's not an x. B, no, -3. Okay, C is repeated, the 1. But D has 4 in the x, so that's not repeated, so that doesn't verify. So we're saying C's our option. But what we're going to do is verify it in our calculator. Okay, so this is what we need to do. We need to go to L1 and L2 and populate those lists with 6, 2, 1, -3, 9, and 4, and then our suspected correct ordered pair of 1 and 5. Okay, how do we do that? Well, the first thing that you need to do, okay, is we are going to enter the 1 as a line, and that will be, oops, that should be an x. Okay, there we go. X equals 1, okay? So go to your y equals and see where I'm highlighted on the x equals, push enter, and let's clear out the -6 and put in a 1, okay? Now, we need to back out of that. Now let's go to the scatter plot, that second y equals again. And number 1, it's already on, so push enter. I'm going to leave it in green, and we have it set up. See where it says mark these? Well, let's look at everything else before we change that. You can change it to whatever you want. So see, on is highlighted. The dot plot is highlighted. That's what we want. Now, if you have any of these others, just arrow over to the dot, the first one, and highlight that. Now, L1 and L2 is what we're going to populate. Now, I'm going to change this, and I'm going to push enter, and that means we're going to see little boxes instead. And then green's fine. Now, if you want to change your color, sure, you can do whatever you want. Okay, hey, how about orange? Let's go with orange, okay? So let's say enter. And then now that we've entered, we have our x equals 1. Everything's great. Let's graph and see what happens. Oh, we can't graph. We have to double check our stat. We need to enter our list. Oh, you lost my mind for a second. Okay. Well, I already had them entered. That's why I was jumping the gun there. But double check to make sure everything's entered correctly. Yes, I see 1, -5, 9, 4, and 1 and 5. Okay, now we can graph. Okay, and looks like our line is the same color. You could change that if you want. So let's go to our y equals, arrow up to our x equals, and actually, we don't even have to change the color. What you could do is just clear that out and go down to one of these others. Let's go to 5, put a 1 in there. Now let's graph. There it is. It changed the color. Okay, you can play with these however you want to, change everything. But the point is that this is not a function, and we have verified that this particular option of C, filling in the blank, does not satisfy the definition of being a function. So now let's go to number 2. Which one of the following statements applies to an even function? Okay, so A, its graph is symmetric about the y-axis. Yes, that is true. Okay, but let's look at the others. Its graph is symmetric about the x-axis. That's not even a function. So that won't work. That would be something like this that doesn't pass a horizontal the vertical line test. And C, it must be one-to-one. No, you can be a function. Something can be a function such as a quadratic, but not pass the horizontal line test and be one-to-one. So that doesn't, not necessarily. So that option doesn't count. So then D, each element must contain even integers. Okay, if you know the definitions, that shouldn't even make sense. Okay, so it is option A. Now let's go to number 3. The graph of an odd function is known to contain the point 7, -2. Which one of the following points must lie on this graph? Okay. Now, we know that the very or smallest exponential, or let's just say we know that y equals mx. That would be to the first power. That's just your standard first linear situation, okay? It's going to be linear. We know that that's odd. All right, we can get rid of this to the first. We don't need it. Okay, so now if we fill in our given, we can come up with a slope and create something to put in our calculator. Take but a second. So we have a y of -2 equals m, and our x is 7. We'll solve for m. Well, obviously, -2 over 7 equals m. So now in our calculator, we need to put y equals -2 over 7x. And now that we've done that and we know that it's odd, we should see the option that's correct as well as our given 7, too. All right, let's do this and see what happens. Okay, let's go to, first we're going to turn some things off. Let's turn off our, we need to go back to that. But we still need to go up. I'm sorry, let me go back. We need to get rid of this one right here. That's going to kind of put a kink in things. So now let's turn off, just go over, turn off the plot, and then go back to y equals. And now we need to enter our negative, and let's do a fraction. Let's just go ahead and put in a fraction. So that's alpha y equals, number 1, 2 over 7. And now let's put in our x. Okay, now we graph that. All right, now we need to go second graph to look at the table. Oh, let's form this a little better. First, I'm going to say let's start at 7. So let's go second window. I'm going to start at 7. And I just want to go up by steps of 1. That means I'm just looking at the integers only. So now let's go back to our second graph. Okay, now we've got something good. So that's our given. But let's see what values. Well, can't have anything that just starts with 7, obviously. So let's go up and look at 2. Well, if we had 2, that's not going to work. Okay. Well, actually, that was 2 would have to be 7, and that's not going to work. Well, I kind of marked the wrong one. Let's just go up and look at -2 so we can see. No, it still doesn't work either. Well, let's look at -7, and both of these, C and D, are -7. Let's see what happens when we get -7. -7, yeah, I see something. That's option D. Okay, and that means C obviously does not work. And what we have done, let's look at the graph. What we're using is the fact that an odd function is symmetric about the origin. Number 4, which one of the following represents a one-to-one function? Okay, to be one-to-one, that means that we pass a horizontal line test, which implies that the y values must not repeat. So let's skip option A right now and go to B. I see that we have repeating 8s in our y values. That won't work. Skip C, let's go to D. We have 3 that is repeating y. So we've just eliminated 2 items. Let's look at C. That's a circle. Obviously, a circle does not pass a horizontal line test. So that is not an option. Well, but wait, it says that if we only look at x greater than 10, that's not going to hold true either, because then we'd have all these values greater than or equal to 10. It's outside the circle. We're still going to pass through every single option that it's discussing. So that's not going to work either. Okay, looking at A, well, I see an odd function. And the fact that that's odd, regardless of this restriction, I don't care about this restriction, the definition of odd implies that it is one-to-one because it will pass a horizontal line test. Well, let's go ahead and graph that. Y equals arrow over negative 2x and carry it up to the third, graph it. Even with a restriction, no matter where you draw a horizontal line, we're going to pass that test, and it is one-to-one. So A is our option. All right, number 5. What is the domain of the function f of x, and it's a rational function? Well, we're just going to graph that. Okay, let's go to our y equals, arrow over. Let's clear out what we have and say alpha y equals number 1. Now we have our fraction set up. Okay, so we need x plus the 4, arrow down, x squared plus 2x, okay, and then minus 15. Now let's graph that. Okay, looks like we have a asymptote at negative 1, 2, 3, 4, 5. So I'm seeing a negative 5 on D right here. And 1, 2, 3, and a 3, positive 3 on the right side. Let's try zoom 7 to see if we get a better picture. Sometimes, no, that didn't give us a better picture. Go back to zoom 6 where we were. Okay, well, now since we can't get the best picture, we could play with it, I suppose. But let's not do that. By the way, handheld sometimes works a little bit better than my emulator that I'm using, okay? I'm going to try it on your calculator. Either way, let's look at our table. So second graph, that's going to give us that good answer, and it does. Look at our negative 5 right here. Error. Negative 5 has been verified. Now let's look at positive 3. We need to go to positive 3. I'm just arrowing down. Oh, verified. It has an error. That means that our domain is all real numbers except these 2. So that has been verified. All right, this is the last question in this video. Once again, highly appreciated that you're watching our videos, liking, sharing, and absolutely, if you've subscribed, you're the best. And I wish everyone happy testing.